Lesson 5, Reasoning with Congruent Triangles. This is part of the Alberta curriculum. So there were, if you've noticed in your workbook, some of the stuff says that it's part of the Alberta curriculum. Some of it says it's part of the WNCP curriculum. This is one of those Alberta curriculum type things. So each of these 5 triangles is positioned differently. So just the orientation is different, but all 5 triangles are the exact same. They have the same size and the same shape. So we say that they are congruent. Congruent means same size, same shape. So the diagrams below show the flags of some of the countries in the world and some of the Canadian provinces. All of the flags shown have some features in common. Each flag contains triangles which are the same shape and size. So 2 triangles which have the same shape and the same size are said to be congruent. So if you look at the flags of America, Samoa, and Namibia, what you have is you have pairs of congruent triangles. Where are my congruent triangles on this one? These 2 triangles right here. These are mine. These 2 triangles are congruent, and these 2 triangles are congruent with each other. Scotland, Jamaica, and Nova Scotia end up having these triangles down here that are congruent to each other. So we're not comparing the Scotland flag to the Jamaica flag. We're comparing the triangles within the Scotland flag, that these are congruent, these 2 are congruent. In my Nova Scotia, if I've removed the coat of arms shield, these triangles here would be congruent to each other. And then when we look at Newfoundland, we have that these 2 triangles are congruent, these 2 and these 2 are congruent. So it says, on each of the flags shown, mark one set of congruent triangles with the letter A and the second set of congruent triangles with the letter B. So for example, if I was looking at Scotland, I could label these 2 triangles with A's and these 2 triangles with B's, because those are the pairs of congruent triangles. So take a moment and do that with the other 5 flags and see what you get. Nova Scotia and Jamaica, my labeling of my pairs of congruent triangles would be very much the same. Where would be my congruent triangles in the flag of America, Samoa? What color are my congruent triangles? The blue ones. And what about in Namibia?
The blue and green.
The blue and the green. And Newfoundland?
The red, and 2 far and black ones.
Okay, so the 2 reds. Are these 4 triangles the same?
Yeah.
So I could label them all B. And those would be all of my congruent triangles. Good. So when we are talking about congruent triangles, there are some properties within my congruent triangles. Triangles have 3 sides, they have 3 angles. If 2 triangles are congruent to each other, that means that their corresponding angles are the same. So angle P would have the same measurement as angle L, Q with M, R with N.
She's not at the office.
Okay. The second condition with congruent triangles is the corresponding sides are equal to each other. So the length of PQ is the same as the length of LM, PR is the same as LN, and QR is the same as MN. And when that happens, we can say that the 2 triangles are congruent to each other. The symbol for congruency is an equal sign with a little squiggle above it. That means that they're congruent. And then the way that we write our letters for our triangles matter. So if we write this one as PQR, we want to make sure that the angle with P matches up. So that was angle L. Q matched up with M and R matched up with N. So we have to write it as LMN. So we need to make sure that if I'm looking at these two triangles, I can see from this notation, angle P should be equal to L, Q to M, R to N. Now, do we need all 6 measurements to show that two triangles are congruent to each other? There are different possibilities. I could give you all 3 angles. I could give you all 3 sides. I could give you 2 sides and an angle that's not contained. So not contained means it doesn't come between the 2 sides. I could give you an angle side angle. So 2 angles and the corresponding side, or the side that's contained. I could give you, and then side angle side, where I have a side, the contained angle, and a side. And then there is angle, angle, side, which is 2 angles and the 3rd side. But honestly, if I give you 2 angles, so the way that that looks is I give you this angle, and I give you this angle, and then I give you one of these 2 sides. So let's say I say it is this side. We'll call it A. Well, if you know 2 of the angles in a triangle, you can solve for the 3rd, because all 3 angles add up to 180. So I can figure this angle out, which then instead of having angle, angle, side, I now have an angle, its side, and another angle. So this angle, angle, side can be rewritten as an angle, side, angle. So we don't need to look at it. So we're going to look at these other 5 considerations. If I give you all 3 angles, so if I said draw me a triangle where one angle is 30, one angle is 40, and the other angle is, not 20, is 110 degrees, would you draw me the same triangle, or would your triangles be different? So let's try it. So if I take my protractor, I start off with drawing a line. And then I'm going to put my protractor on one point, or the end point of that line, and I'm going to draw a 30-degree angle. And then I'll use my ruler to draw that. And then I'm going to draw my 40-degree angle. And then what's left over this angle in here should be 110 degrees. That's my 110. So compare your triangle with a neighbor and see whether or not, are your triangles the same size? Yes or no? Pardon? No. So if all three angles and two corresponding triangles are congruent, can I say that the two triangles are congruent? No, I can't. So this is not a test for congruency. So angle, failed. So then the next one that we have is all three sides. So if I wanted to draw a triangle where all three sides were the same, could we draw the exact same triangle? So let's try drawing a triangle that's 3 centimeters by 4 centimeters by 5 centimeters. So the way that we'll do that is we'll actually use our compasses to help us. And you'll also need a ruler. So I start off with my line that's 4 centimeters in length. Use the compass to measure out 5 centimeters. Then I'm going to put the point of the compass on one end of that line, which will become a vertex of my triangle, and I'm going to draw an arc. Then I'm going to take the compass and make a line that's 3 centimeters, because that's my measurement that I have left. And then what I'll do is I'll take that compass and put the point on the other end of the line. And I'm going to draw another arc. And that arc is going to intersect the first one. And if I draw joining points to that from my two vertices, there's my triangle. Now this arc here, that was my 5 centimeter from this point. So here's my 5 centimeter line. This is my 3 centimeter and my 4 centimeter. Compare your triangles. Did you draw the same triangles? So you're going to draw me a triangle where one side is 1 centimeter, one side is 2.5 centimeters, and the angle that's not in between them. So if I was to draw this out, if I was to just quickly sketch a triangle, this would be my 17, and those would be my other two measurements. Or my other two measurements, or the 17 could be on this end up here. But the 17 does not come between the two sides. So I've drawn my first line that's 1 centimeter. Now if I draw my other line that's 2.5 centimeters. 2.5 centimeters. And then I need my angle that is 17 degrees. And my 17-degree angle has to be here. So 17 degrees. So there's my triangle. No, it's not. So how do I make it follow that? Can I?
Could you just put your compass on the one and put it on 2.5 and then meet this?
So like that? There's my triangle. Compare your triangles to